In this video, we're going to look at the meanings of the equal sign, part 1. So part 1 is going to be when we're looking specifically at numeric values, and in the next part we're going to look at variables. And notice I put the word meanings, and the reason I put meanings is that if you're just looking solely at a symbolic representation of math, okay, the equal sign could mean different things depending on the context. And specifically, it usually means different things depending on what the directions are asking you to do. Okay, so it's very important that you read the directions, and then that will guide you in what you're being asked to do in the problem itself. But also it helps to have an understanding of the basic structure of the mathematical expression so you can kind of figure out what you're being asked to do. So that's what we're going to do here. Okay. So first, suppose you're asked to perform the indicated operations or simplify, and you're given 4 plus 2 equals blank. Okay, and you've seen this problem many times in your life, and I think you'll agree that you would write the number 6. So performing the indicated operations, in this case it was just addition, but it could be multiple operations. It could have been 5 times 4 plus 2 minus 7. Okay, or if you're asked to simplify, it means when you're given specifically numbers, your answer should be a single number. Okay. Now simplifying is going to seem pretty much the same when we're working with numbers, and a lot of these are going to seem different when we start working with expressions, with variable expressions, excuse me. So simplifying means to rewrite an expression in the simplest form possible. And again, when you have 4 plus 2, the simplest way to rewrite that is as a single digit 6. Now here's one that may seem a little bit different. Find an equivalent expression. Okay. So we're given 4 plus 2 equals, and again we probably want to write 6 here, and that actually wouldn't be wrong, but let's see what it means to be equivalent. So two expressions are equivalent if they can be simplified to represent equal quantities or expressions. Okay. So 4 plus 2 is equivalent to 6, so we could write 6. Okay. But notice there's a lot of different things we can write here, a lot of expressions that when you simplified or perform the operations like mentioned here, they would also equal 6. So we could say 4 plus 2 equals 5 plus 1. 4 plus 2 equals, well, 12 minus 4 minus 2, that's also equal to 6, so these are equivalent expressions. 2 times 3 equals 6, so these are equivalent expressions. So notice how this is more like the balance scale. Okay, you're not just finding an answer where you're computing what's to the left, you're finding an expression that's equivalent to the one on the right. Let's look at two other types. Evaluating an expression. Again, this seems the same as simplifying or performing the operations, but it's definitely going to be different when we have variables. But it means to calculate. You need to perform any operations possible and give the final result. So this is shockingly 6. Okay. Now we have solve an equation. Solve the equation by filling in the box with the number that will make the equation true. So we talked about what it means for an equation to be true. So for some values in the box, this would not be true, and there is a value where it is true. Okay. So I want you to use the word solve very carefully now that you've entered algebra. So some students might look at this and say, oh, I'm going to solve this. Okay. And we're not really, you can call it solving, it's not officially wrong, but solving officially means finding the number that makes the truth value of an equality statement true. And here, if you did put 6, that is officially solving, but I want you to compare and contrast that with this expression here, where you're finding a value for this box. Okay, it's to keep this equation balanced. Okay, so it's a very subtle distinction, so I want you to take time to think about this as you're reviewing this section in general. So notice in this case there's one such value that makes this equation true, and that would be putting 3 in the box. So notice on the left we have 4 plus 2 is 6, on the right we have 3 plus 3 is 6. Now, occasionally we'll look at these error analysis. So things that people do, so you can know why they do them if you're one of those people. Okay, and then you can start changing your behavior. So one of your classmates writes the answer below. How do you think your classmate is interpreting the equal sign, and how would you convince them that the answer is 3? So looking at this, your classmate wrote 6 in the box. Okay, you've seen a lot of 6s lately. So your classmate is thinking of simplifying or perform the operations to the left of the equal sign. And I want you to think about this, because really, if you cover up this plus 3, this is what you were asked to do probably up until 7th or 8th grade. You would think of this as reading it from left to right, and you'd say 4 plus 2 equals 6. Okay, this plus 3, who knows what that means? Maybe I'm going to add 3 later. Okay, that's actually not what it means, but that's how you tend to interpret it after all this time of reading these from left to right. Okay, so this person is thinking, add the 4 plus 2 and the answer is 6. Okay, the way to convince them that the answer is 3 is perhaps maybe look at a balance scale. They have to look at this entire expression and this entire expression, and that's what we want to be equal. This equals 6, 6 plus 3 equals 9, 6 does not equal 9, so this is a false statement. Okay, so now let's do some examples with scales. For each of the following, fill in the blank with one or more values or symbols. Use the balance scale to visualize the equation. Then state what the equal sign symbol represents in this given situation. So we're going to write 2 things. Either we are doing something like simplifying. So I know we looked at 4 in general. But simplifying, performing the operations, evaluating, they're all pretty much the same when we're dealing with numbers. Or solving. So here, on this side, we have 8 and 4. And on the right-hand side, we know we have 5. And we want to find the value that would balance the scale. Okay. So notice, well, 8 and 4 combined is 12. So we could think, what would I add to 5 to get 12? And the answer would be 7. Then 7 plus 5 is 12, and the equation is balanced. Okay. So notice in this case, we were solving the equation for a missing value. We were balancing both sides. Let's look at the next one. So here we have all the values and operations are on the left-hand side. So we have 4 and 3 and 5. Okay. And we want to know what to put on this scale, this side of the scale, to balance the equation. Notice we could put 4 plus 3 plus 5. That would probably be the easy, sneaky way to do it. And that would be finding an equivalent expression, because we weren't given directions here. Okay. Don't worry, in general, you will always be given directions. Here we're just playing around with the ideas to get a feel for these different types of directions. Okay. But you would typically solve this by finding 4 plus 3 plus 5. You would add the 4 and 3, and I just said solve this. I should say simplify or add. 7 plus 5, and 7 plus 5 is 12. Okay, so we will put 12 on this side, and we would say this is simplifying or performing the operations. Let's look at the next one. Here on the left-hand side, we have 4, 3, and 5. On the right-hand side, we have 5, and we're asked to find what would we put on the scale to make this balanced. Let's think about something here. Okay, notice both sides have a 5 on it. Okay, if it's balanced now with some, let me put in a secret box. Okay, so this is whatever value this is what balances it. I think you'll agree if I remove the 5 from both sides, it would still be balanced. Okay. And we're going to talk about this in a lot more depth later, but I just want you to see this and see if it makes sense to you. And then we know the box must be the same or equivalent to 4 plus 3, which is 7. Okay. And here we were solving, okay, because we were finding the value that balanced both sides of the equation with values on both sides. Okay. Notice on the left-hand side we have 7 plus 5 is 12, and then 5 plus what equals 12? Well, that would be 7. Now on this one might seem weird. You might not like this. Okay, I don't really like it either, because we have a blank spot and then adding all these things, but it's on the other side of the equal sign. What does that even mean? So I'll put the 3, 5, and 7 here. Now notice, it doesn't matter what side of the balance scale you put the values on. It doesn't change it at all. Okay, meaning that I could put 3, 5, and 7 here, or I could put it here, and it would be equivalent. You could think of how you would look at this scale from either direction, and it wouldn't matter. Okay, so this totals 15, so I'm just going to put 15 over here. Okay, and we could say 15 equals 3 plus 5 plus 7. And I just want you to note that we could write this in the other direction. Okay. And this is actually called the symmetry property of equality. You don't need to know that, but you basically, the fancy name, but you basically need to know that you can change, with an equal sign, you can change what side both of the expressions are on, and it's still equal. Okay. So here we were just computing, so we would say we'll use simplifying. And now let's just look at one last error analysis for this video. It said Donald was working a problem and wrote the string of equations below. How does this misrepresent the concept of equality, and how would you fix it? Okay. So let's look at this. This is a string of equations. Okay, here's an equal sign, here's an equal sign, here's an equal sign. And you probably frequently compute this way. So you're given 3 operations to perform, and you perform one at a time, and you work from left to right. But there's something problematic here. So what we're going to do, and what I suggest you do in general, is instead of writing, sometimes because of space issues, you may write your equations from left to right, but it's horizontally, but it's really better to write them down, and I'm going to show you downwards vertically, and I'm going to show you why. Okay. So here first we'd perform the addition, and we have 11. If we want these two to be equal, we have minus 4 minus 2. Okay, so notice these are equivalent expressions. I just replaced 3 plus 8 with 11. The next step is I do 11 minus 4, I get 7 minus 2, and then I get the result of 5. So this is a string of equations, or a string of equivalent expressions, like we defined it a few slides back. This is equivalent to this, this, and 5 would be the simplest form. Okay. Now let's notice what the student did up here. This is the same, but the student computed 11 and left out the minus 2. Okay. Now this may not seem like a big deal, but notice 11 minus 4 is 7. Okay. And if we look at this string of equations, this is basically saying if we pick this piece right here and the last piece right here, this is saying 7 equals 5, which is false. So this is not a true string of equations because we have a false statement in the middle. Okay. So make sure when you're doing your computations or your simplifications in algebra, okay, for each step, right, you'll perform one operation of some sort. Make sure you write everything from the expression. Don't just look at the one piece you want to do next, okay? Because this is really thinking of equality in the old way, thinking of the, oh, I compute 3 plus 8 and that's 11. You're not thinking this is equal to this entire expression. You're thinking it's just the answer to computing whatever you needed to compute. Okay, so it may seem like a small idea, but it's really a big idea that's going to help you navigate your way through equations and algebra. See you at the next video.